2017 Leaving Cert Higher Level. Paper 2, question 7 is an area and volume question. You're given these diagrams: a sphere, an empty sphere, and these two solid cones inside a cylinder where they just about fit inside. So you're asked to show that the capacity of the empty space in the cylinder, these two bits here, is equal to the capacity of the empty sphere. Okay, well, we know a sphere is 4/3 pi r cubed. If we don't, we look it up in the table, and it's a capital R they're giving us here. The volume of a cone is 1/3 pi r squared h. And we have two of them in this case, so multiplied by 2 is going to be 2/3 pi r, capital R, squared h. And the volume of a cone, or the volume of a cylinder, is equal to pi r squared h. So for our cylinder, we can see that h is actually 2r, these two here. So we have pi times r squared times 2r, which is pi 2 pi r cubed. So we're dealing in thirds here, so we have 6 pi r cubed over 3, which is the same as 2 pi r cubed, minus 2 pi, my h in this case is r2, so 2/3 pi r squared, or is 2/3 pi r cubed, so minus 2 pi r cubed over 3, which is 4 pi r cubed over 3, which is equal to the volume of a sphere. So just write that down: equal volume of empty sphere. In part B of this question, you're told for the remainder of the question, r is equal to 12. Water is poured into both the cylinder and the sphere to a depth of 6 centimeters. Find AB, the radius of the circular surface of the water in the sphere, and give your answer in this third form: A root B centimeters. So we're looking for this one here. Well, if I create a triangle, which is what I'm going to need to do here, I also have, well, the radius we can see here, r is 12 from this 12. So this has to be 6 because 6 is at the bottom. So I just take that triangle out, or do I need to? I can just write the square root of 12 squared minus 6 squared. You guys are good enough to do that. So that's equal to the square root of 144 minus 36, which is root 108, which is 36 threes. So that's 6 root 3 centimeters. Part 2, you're asked to find CD, the radius of the cone at water level. So if we look at this triangle here that I'm going to draw over in blue, we can see that we have two similar triangles here. So if I take the big one, we have a 12 down here. This is an R. We also have a 12 along the side. And if I take the smaller one, we're looking for this side here, CD, so we'll call this X. And we have this 6 here to help us. So that means that this is 6 because it's going to be 12 from here all the way up to here. So you can see here that X is actually going to be equal to 6. So if we start with the first triangle, 12 over 6 is equal to 12 over X. So this side over this side is equal to this side over this side. So X has to be equal to 6 centimeters. That's CD. Part 3, we're asked to verify that the area of the surface of the water in the sphere is equal to the area of the surface of the water in the cone. I wrote sphere, cylinder in fact. So let's have a look. Okay, so we've got this area of water here. So it's a circle, so it's going to be the big circle minus the little circle. So the big circle is pi r squared, and so is the little one. And we have two different radiuses. We have a 12 and a 6. So in the cylinder, we have pi r squared for both. So we have pi by 12 squared minus pi by 6 squared, which is 144 pi minus 36 pi. We can leave it in terms of pi here. That's 108 pi. And if we look at the sphere, we got this was the radius. So again, it's a circle. So pi r squared, and it's 6 root 3. So the sphere, pi r squared, so pi by 6 root 3 to be squared. So pi by 36 times 3, which is again 108 pi. So they are the same. In the last part of this question, you're told the mathematician Cavalieri discovered that at the same depth, the volume of water in the available space in the cylinder is equal to the volume of water in the sphere. Use this discovery to find the volume of the water in the sphere when the depth is 6. So it's the same diagram. Let's have a look what they mean. So what's the volume of water? What is this volume of water in here? That's what we're asked to find. The depth of water in the available space. And the available space is the bit around the cone where the water can fit in all these little areas. So it's looking at, we have a cylinder. We have a cylinder here of height equals 6 and radius equals 12. That's the cylinder part all the way around. And then we got to take away this bit of the cone in here. So to get that bit of the cone, we need to get the volume of the full cone and then take away that top part, which is also a cone. So let's have a look at doing that. So the cylinder, the volume is pi r squared h. So it's in terms of pi here, so we can leave pi alone. So it's pi. And the radius is 12. And the height is 6. And 12 by 6 by 12 is 864. 864 pi. So that's what would fit into the cylinder if there was no cone there. So let's look at the volume of the full cone. The radius is 12 and the height of the full one is also 12. So the full cone, it's a third pi r squared h. So a third by pi by 12 squared by 12. So that's 12 by 12 by 12 divided by 3, which is 576 pi. And then we need to take away the top part of the cone because that's not in the picture. So the top part of the cone, which is also a cone shape, top of the cone, because we're just looking for the bit. So we need to take away whatever value that top of the cone is. I'll make it into a cone. So what's the volume of this part of the top of the cone? It's the height is going to be 6. The radius is still 12. No, the radius is 6. We worked it out in the previous part. The radius was 6 in here. So we're looking at pi, 1/3 pi by 6 squared by 6. So that's 216 divided by 3, which is 72. 72 pi. So 576 minus, put in the pi, minus 72 pi is equal to 504 pi, or 504. So 864 minus 504 looks like 360 pi is the volume of water that's in the cylinder, but it's also in the sphere. So that's Cavalieri's understanding or discovery, not the guy that played for Paris Saint-Germain.